Hey everyone. So in this video, I want to take a look at some special angle relationships that exist when we have two parallel lines that are cut by a transversal. So let's start by making a diagram. So let's start with two parallel lines. So remember, parallel lines mean that they never intersect. And I'm going to indicate that these are parallel by putting some directed arrows on them. So that symbol there, that means that these are parallel. A transversal is a line that intersects two or more other lines. So I have my two parallel lines, and these are going to be cut by a transversal. So let's label these lines. I'm going to say that my transversal here will say that this is T for transversal, and then my other two are parallel. I'm just going to name these M and N. So what we know is we know that M is parallel to line N. So now let's take a look at the angles that we have. So two parallel lines that are cut by a transversal, we end up with 8 different angles. So I'm going to label these 1, 2, 3, 4, and then we'll do 5, 6, 7, 8. So to start off with, let's think about what angles, which ones do we know are congruent? So we already know vertical angles are congruent. So for example, angle 1 and angle 4, these two are going to be congruent to each other because they're vertical. And angle 2 and angle 3 are going to be congruent because those two are vertical. So we know that angle 1 is congruent to angle 4, and we also know that angle 2 is congruent to angle 3 because these are vertical angles. And we actually have the same relationships down below here for 5 and 8 and 6 and 7. Now, the interesting thing is going to be the relationships between the angles in this first group of 4 and then my second group of 4 down here. So let's make an argument. So let's take a look at how two of these angles are related. So I'm going to look at angle 2 and angle 6. So if I highlight angle 2 here, my argument is that angle 2 is the same size as angle 6. So this can be argued with a transformation. So if I take angle 2 and I translate it, or I slide it, so let's say I slide this down our transversal, so I'm basically copying and pasting it. If I slide it down the transversal, I can see that it is exactly the same size as angle 6. So that means that angle 2 and angle 6 are congruent. I also know that 6 and 7 are congruent because they're vertical angles, so these two are the same. So that also means angle 2 is the same as angle 7. Well, angle 3 was the same as angle 2, so angle 3 and angle 6 are congruent, and also 3 and 7 are congruent. So we can finish writing this out. So angle 2 is the same as angle 3, which are both the same as angle 6, and that's the same as angle 7. We can make a similar argument for angle 1 and angle 5. So angle 1 and angle 5 are congruent because we could translate that down and we would see that those are the same. And then 5 and 8 are congruent because they're vertical angles. So angle 1 and angle 4 are congruent to angle 5 and angle 8. So we end up with these two pairs, these two sets of 4 angles that are congruent to each other. And these have certain names. So the first ones we talked about were corresponding angles. So corresponding angles are angles that are in corresponding positions. So for example, angle 1 and angle 5, these two angles are corresponding. They're both on top of the parallel lines, and they're both to the left of the transversal. So angle 1 and angle 5 is one pair of corresponding angles, and they're congruent to each other. And then we can work our way around and take a look at the other ones. the first ones we looked at were angle 2 and angle 6. Those are congruent. And then on the other side of things, we have angle 3 and angle 7 is a pair of corresponding. And then the last one, we have 4 is congruent to angle 8. So 4 and 8, so these are both underneath, they're both below our parallel lines, and they're on the right side of the transversal. So they're in corresponding positions. The other special angle pairs we have, one of them is called the alternate interior angles. So the alternate interior angles, the name tells us everything we need to know. So alternate, one is on one side of the transversal, one is on the other side. Interior, they're in between our parallel lines. So my two pairs of alternate interior, we have angle 3, and that's congruent to angle 6. So angle 3 is on the left-hand side of the transversal, and angle 6 is on the right-hand side, and they're both in between my two lines. And then the other pair we have is angle 4 and angle 5. We also have alternate exterior angles. Similar to the alternate interior, the alternate means one's on the left-hand side, one's on the right-hand side of the transversal. And then exterior, they're going to be on the outside of our two lines. So for example, angle 2 and angle 7. So 2 is on the right-hand side of the transversal, 7 is on the left-hand side, and they're both outside our two lines. So angle 2 is congruent to angle 7. And our other pair, we have angle 1 is congruent to angle 8. There's one more special pair, but these ones are actually, the relationship is a little different. So these are what we call consecutive interior angles. So consecutive interior angles, again, the interior means that they're in between our two lines. In consecutive, they're right in a row. So for example, what we have is these two angles, they're both on the inside and they're consecutive. It's one after another as I move around. In this case, these two angles, they're not congruent to each other, but what we can see by taking a look at the relationships we have, they're actually supplementary. So the measure of angle 3 plus the measure of angle 5 is equal to 180 degrees. And the same thing is true on the other side. So angle 4 and angle 6. The measure of angle 4 plus the measure of angle 6 is equal to 180. So all four of these special angle pairs, these are all theorems. So the corresponding angle theorem tells us that these relationships exist, that these angles are congruent. Or the alternate interior angle theorem tells us that these two pairs of angles are congruent. So what that gives me is if I have two parallel lines cut by a transversal, I'm able to find out a lot of angle measures. All I need is one to start with, and we can find the rest. So just as an example, let's say we have two parallel lines cut by a transversal, and let's say we know one of these. Let's say we know that this first one is 120 degrees. Well, if I know that, I can actually find the other 7 angles using these angle relationships. So if this one is 120, then the corresponding angle, this also has to be 120. They're in corresponding positions. If this one's 120, its alternate interior angle also has to be 120. Or I could use vertical angles to say that that's 120. If my initial one here was 120, the alternate exterior angle also has to be 120. And then for our other angles, I know that the consecutive interior are going to be supplements. So 180 minus 120, this angle has to be 60. Its alternate interior angle has to be 60. And then again, we have some options here. Maybe I'll use vertical angles, or we can use corresponding angles to say that those outside ones are also 60. So 4 theorems, 4 special types of pairs of angles, and that gives us a way to find out a bunch of different angle measures.